In processes, the most important thing that we need to denote is communication. In processes, we need to communicate with one another. If an organization runs a process, it wants to achieve a certain goal for a certain case, for instance, a customer. In order to reach that goal, it's very unlikely that only one person is involved who doesn't communicate in any way with the customer or with colleagues or with back agencies. Therefore, we need to denote communication in process models. And we've seen already quite a few of those ways of communication, how we can model them in BPMN. For instance, the sequence flows give us the way to model how the tokens move through the process. Messages are denoting communication between pools, so different organizations or different process participants. However, these two are in some sense quite limited because, well, a sequence flow goes only within one pool and a message goes only between two pools, but only like one-to-one communication. So it's not just communicate with everyone. It is point to point. We have to know that who we are sending it to and that person is actually listening in order to be able to use a message. There, signals come into play. And in this video, I'm going to show you what these do and how we can use them to model. Signals are kind of broadcast. So rather than point-to-point communication, this signal means information is broadcast to the whole world. And actually, quite literally to the whole world. So a signal, if we send it, it can be received by anyone in any pool, in any lane, anywhere in a process hierarchy. So yeah, a signal is a really kind of really broad broadcast. We shout it to everyone. It's like in the middle of a city on the highest mountain, you say, you have a megaphone and you shout information to the whole population. That is a signal. It can therefore all be sent and received by multiple parties at the same time. So if one party sends it, anyone who is listening to that signal will get it and may act on it. This is how you throw a signal. This little triangle, and of course it's a throwing event, so it has a filled triangle, and we have that in two shapes, the intermediate and the end event. And these do exactly what we can expect based on their shape. They throw a signal for the intermediate event somewhere in the middle of control flow, and for the end event, they send a signal and then end the process. So these broadcast something, some information. Now, how to capture them? Well, first of all, we can start a process on receipt of a signal using a start event. Second, we can wait for a signal if we are in the middle of a process using an intermediate catching event. We can stop a subprocess on receipt of a signal using these two constructs. So on the left we have a boundary event, and on the right we have an event subprocess. These are interrupting. So these wait for, on the left, if the activity is attached to, on the right, the subprocess it is in. While that is running, if a signal is being broadcast anywhere in the world, then these will stop the activity or the subprocess and then execute something based on that signal. They also exist in non-interrupting, and these will simply catch the signal as long as what is attached to is running and execute some other tasks or subprocess as modeled. So signals are really flexible. So anyone can receive them, anyone can send them, and you can act on it in any type of construct in BPMN that you can imagine. So they are very flexible. And let's look at an example of how we can use signals. In this process, we handle a purchase order. And what we want to add is that the customer at any point in time can cancel the purchase order. Now, okay, we've can use a standard boundary event for that, but let's say that this organization isn't so friendly or so naive to just allow customers to cancel a purchase order, because already cost may have been made, or they just want to make some extra profit out of customers changing their mind. So let's say that this organization wants to charge a penalty for that. Of course, once the customer requests a cancellation, we cannot impose the penalty directly. We need to confirm with the customer, like, hey, you want to cancel? I'm going to impose a penalty. Do you agree to pay that, or would you like to continue with the purchase order? So we need to do two things. We need to handle the cancel message from the customer, and we need to verify with the customer that he or she wants to cancel and pay the penalty. And that we're going to model using a signal. Kind of a double check with the customer. Hey, do you want to pay this penalty? So for the first part, we have a non-interrupting message event. And that's kind of the first point of impact. And this is non-interrupting. Why is that? In this case, if the customer sends a cancellation message, we're not actually canceling yet. We don't do that immediately. We first ask the customer if the customer agrees to pay the penalty. So if this boundary event would be interrupting, then we would stop the purchase order handling process immediately on receipt of a cancellation. And that's not what we want. We want to continue with that until the customer has approved to pay the penalty. So that's why this is a non-interrupting boundary event. If we just follow the process, then we're gonna compute the penalty, then send that penalty to the customer, and then wait for an answer. Either the customer says, okay, I don't really like to pay the penalty, just continue with the purchase order. So that is this part, we get a continue message. Then this side branch just finishes in an end event. So notice that as we did not interrupt the handle purchase order process, this has no influence at all on this handle purchase order. So the side branch goes to an end event. So that's handled. We've handled the cancellation request, but there's no action on it anymore, right? On the other hand, if the customer says, okay, I will pay the penalty, so sends kind of a cancellation confirmation, then we're going to use a signal. And this signal is an end event, and this signal is going to broadcast to the whole world, cancel. Okay, so we have a signal and we have a sub-process that is still running and that now needs to be cancelled. So for that, we use a boundary event called cancel, and that boundary event is interrupting. So at this point, when this signal comes, we know that the customer has accepted the cancellation penalty, and hence this is a interrupting boundary event. So when that signal comes, then the handle purchase order sub-process will be stopped immediately. So notice that these signals are always named, so they must have a label, and that label determines what signal it is. Of course, because broadcast is so broad that everybody will hear it, we must limit that somehow to only listen to the right signal, so hence the label. So signals have a label, and this boundary event will only respond to a signal with the cancel label. So with that boundary event, we have modeled that the purchase order is cancelled after confirmation, and then we can start a new subprocess in order to charge a penalty. This wraps up this video on signals. Signals are broadcasting communication. So it's communication between any type of participants within the same pool, other pools within your same subprocess in a different part of the hierarchy. So it's a very flexible way to establish communication between parts of your process. Notice, however, that also comes with a downside, and that is that this provides a way of communication that is more or less invisible in the process model. So use it with care.